Continuity and differentiability, exercise 5.6. We have completed 10 questions. Now we will solve for 11th one. X is equal to square root of a to the power sine inverse t. Y is equal to square root of a to the power cos inverse t. So we have to prove dy by dx is equal to minus y by x. So already they have given the derivative of the parametric equation, that is minus y by x. So let us prove this. Given parametric equation, x is equal to square root of a to the power sine inverse t, y is equal to square root of a to the power cos inverse t. So here t is the parameter. Now we have to prove dy by dx is equal to minus y by x. But we know that dy by dx, we can only find dy by dx if we'll find dy by dt and divide by dx by dt. So provided this dx by dt is not equal to 0. So let us label this as 1. Though we have to prove this, we have to find dy by dt divided by dx by dt. So let us differentiate the two parametric equations. So here we have x is equal to square root of a to the power sine inverse t. Right? So now we can write this as x equal to a to the power sine inverse t to the power 1 by 2. So we can write square root in the rational exponent form, right? A to the power sine inverse t to the power 1 by 2. Now we can also multiply this. X is equal to a to the power 1 by 2 into sine inverse t. 1 by 2 into sine inverse t. So how did we get it? From the law of exponents, a to the power m, and again if it is raised to the power n, we will write a to the power mn from the law of exponents. So this is raised to an exponent and it is again raised to a power, so we can multiply these two, right? So we can multiply these two. Now we will utilize this to find dx by dt. So here we have x is equal to a to the power 1 by 2 sine inverse t. Since we want dx by dt, we have to differentiate both sides with respect to t. We have dx by dt is equal to d by dt of a to the power 1 by 2 sine inverse t. Now this implies dx by dt is equal to, so we have a formula when you have function of this type, a to the power function, that is constant to the power function. So derivative of constant raised to a function will be constant into constant to the power function into log of that base to derivative of the function. So here it is a to the power f of x, right? A to the power f of x. So first we have to write a power f of x. So a to the power of 1 by 2 sine inverse t. Then they have given log a, the base we have to write, or the constant we have to write. Here also we have a, so we will write log a. So if we had some other constant like d, e, we could have written log d, log a, but here we have a, so we will write log a. Then we have to differentiate the exponent, right? So now here we cannot write x because it is with respect to t, so we will write d by dt. And what is the function here? F of x, that is 1 by 2 into sine inverse Now this implies dx by dt is equal to a to the power 1 by 2 sine inverse t log a. Now we have to differentiate d by dt of 1 by 2 into sine inverse t. So here we have constant into function, right? Constant into function. So we will take out the constant and we will differentiate the function. Now this implies dx by dt is equal to, so I'll write this first, 1 by 2 log a to the power 1 by 2 sine inverse t. Now derivative of sine inverse of x is 1 by square root of 1 minus x square. So but we have t, right? So we will write 1 divided by square root of 1 minus t square. So now this is 2. So now we want dy by dt, right? So now we will write y is equal to square root of a to the power cos inverse t. So we will write y is equal to a to the power cos inverse t. So we will write to the power 1 by 2. If they have given cube root, you will write 1 by 3. Okay, so now from the law of exponents, we will write a to the power 1 by 2 into cos inverse t. So now we will differentiate this. So y is equal to a to the power 1 by 2 cos inverse t. So we will differentiate with respect to t. We have dy by dt is equal to d by dt of a to the power 1 by 2 cos inverse t. So now we will apply this. In the place of f of x, we have half cos inverse t. So this implies dy by dt is equal to a to the power 1 by 2 cos inverse t log a, then d by dt of half cos inverse t. Now this implies dy by dt is equal to a to the power 1 by 2 cos inverse t into log a. So constant into function, so we will take out the constant and we will differentiate the function. This implies dy by dt is equal to a to the power 1 by 2 cos inverse t log a 1 by 2. So derivative of cos inverse function is minus 1 by square root of 1 minus x square, but we will write minus 1 by square root of 1 minus t square. So therefore dy by dt is, so we will write minus 1 by 2 log a to the power 1 by 2 cos inverse t 1 by square root of 1 minus t square. So this dy by dx is equal to, first we will substitute dy by dt, that is minus 1 by 2 into log a to the power 1 by 2 cos inverse t 1 by square root of 1 minus t square divided by dx by dt. So dx by dt is 1 by 2 log a to the power 1 by 2 sine inverse t 1 divided by square root of 1 minus t square. So if you observe here, there are many terms which is there in the numerator and denominator. So 1 by 2 will be 1, log a by log a will be 1. This we cannot cancel because they are different. But 1 by square root of 1 minus t square, 1 by square root of 1 minus t square are same. So this will be 1. So we are left with this as well as minus sign. So therefore dy by dx is equal to, we'll write minus sign and we will write a to the power 1 by 2 cos inverse t divided by a to the power 1 by 2 sine inverse t. Now this is equal to So if you observe this, a to the power 1 by 2 cos inverse t, that was y, right? 1 by 2 cos inverse t is y. So we can write y, and a to the power 1 by 2 sine inverse t, so that was x for us, so we will write x. So therefore we got dy by dx is equal to minus, so here we have to write minus y by x, right? So we have proved. So hence we completed 11th one, and here exercise 5.6 got completed.